Hello everyone and welcome to a new episode of All Things IDA. In this episode, I'm gonna be starting a series to talk about Hiew, which is a hex editor also known as Hacker's View. Hiew is a very powerful hex editor. It is text-based, but unfortunately it's not super friendly to use. Hiew is created by Eugene Saslikov, who is also known as Sen. Hiew existed since a long time ago. I was using Hiew around 1995, back when I discovered it, and I've been using it ever since. So it takes a long time to actually get used to how to use Hiew. In this first video, we're gonna cover the basics of Hiew and also start talking a bit about the header view of known executable files and how to do basic operations. And in future videos, we'll advance to more advanced topics. So let's get started. Okay, so first things first. If you've never used Hiew before, let's show you where to get it from. So you can get Hiew from hiew.io. And from there, if you don't want to buy it immediately, it's not free. You can get the demo version first, play with it, and then decide to buy it depending on which plan you want to buy. Please support Eugene. This tool really saves you time, and you will see how useful it is. Now that I have Hiew installed, I put it in my tools folder. A good use of it is to really hook it up with your file manager. So I usually use the Altab Salamander file manager. I simply go to the configuration in that file manager and set up Hiew to be an alternative viewer for all files. So I select star.star and select the viewer to be external viewer and Hiew. Like this, if I'm in the file manager, simply invoke Hiew by invoking the alternative viewer in that file manager. So here it's Alt F3 for that file manager, and directly takes me to Hiew. When we first invoke Hiew, we see the text view basically. So that's a regular text view. Without spending too much time on that, the text view is really ideal for large text files. It's way much more powerful than your text editor. So if you have a large file in the order of gigabytes, then opening it with Hiew and searching and so on is way faster, and that's useful for large log files and so on. So here's a text file. Invoke it with Hiew, and you can do regular viewing operations on the text mode. You cannot edit on the text mode. You can view, you can search, and so on. So just quickly about the basic of the Hiew interface, which is common knowledge for the future videos. So as it stands, since Hiew is a text-based UI, it doesn't have graphical menus. Instead, the menus have been designed to be here at the status bar, and we can see those numbers. Those numbers map to function keys. So as it stands here, 1 means F1 and 2 means F2 and so on. You will see some function keys are empty. That means the functionality is not available in the current context. So depending where you are, what view you are, and so on, some things will be available, something will be disabled, and some are completely missing. So just keep that in mind. So the functionality of Hiew, the stuff we can do, are mainly available through the function keys. Now there are other hotkeys that are not directly visible in the function keys. We'll cover as we go along. So one of them is like the calculator. For example, if I press Alt equal, then I have a calculator. This is not directly evident when I press, when I see the status bar, I don't see any indication for that. And when you invoke a functionality, usually it might come with its own sub-functionalities. So we are in the calculator right now, and in the calculator I only have F1. To close the dialog, so here if I press F1, I can see the help of the calculator and how powerful it is and what it can do. To close any dialog, most of the dialogs, and even Hiew, can be exited by pressing escape. So right now, I'm in the calculator, pressing escape, it closes. Now I want to exit Hiew. Although this is configurable, what I'm going to say next, you can configure it not to close when you press escape. By default, you can press escape, it will close Hiew. Or as we see here, also it has a dedicated F10 key to quit. So today we're gonna be mentioning how to look at the PE file formats with Hiew, and that's a very powerful feature in here. So I opened an executable. I'm in the text mode. Now, to get more contextual information about file format, text view is not enough. So now how do we switch views? We can press enter, for example. So when I press enter, it cycles between different modes or views in here. So it's equal to the F4, but 1 second. So let me press enter right now. And it switches to the second mode, which is the hex view. And that's what you are used to in your hex view. And one more mode, if I press enter, it has the disassembly view as well. And that's very, very powerful. So enter and so on. Or we could have pressed F4 and selected we want hex view, disassembly view, or text view. So we want to work in the hex view. So we open the binary and we're looking at it. Before I usually open a binary in IDA, I open it in Hiew just to get a quick idea what I'm dealing with. So here I open the binary and I'm in the hex view, and I take a look. I can see just the structure. I can see MZ, I can see PE, and I can see the sections and so on. But this is basic, really. Hiew offers us much more powerful features than just a regular hex view. So for that, since I'm already in the proper mode, I have different functionalities than in the text mode. One of them that's relevant for today's topic is the header functionality. So if I press F8, now I have the PE header view. Hiew supports not just the PE file formats, support Linux and Mac executables as well, and also PE Plus and so on. So when I press F8, I see the important pieces of the PE headers. There are more information in the PE header, but that's what the dialog, the F8 dialog shows us. And since we are in this dialog, we have additional functionalities as well. We can see these are contextual functions that are only available for a known file format and within that dialog. So we are in that dialog, we are in the PE file, we have certain functionality. In that header dialog, we have, for example, things that are relevant for us as reversers. Maybe we want to see how many sections. Maybe we want to look at entry point value. We want to look maybe at checksum. This could be relevant, especially if we want to edit it. We're patching a driver. Drivers are peculiar about the checksum value. Just let you recompute it for us if we patch a driver. Of course, if the driver is not signed. The machine, the date, and so on. So these are good, quick glance. Now we can do additional stuff more than this one. So now we're in the header view. We can choose to actually edit the header. So if I here, we can see number 3, that means F3. So if I press F3, now I have a larger view where I can edit most of the fields. And not only that, Hiew also shows us where is the physical offset of that signature. So here is the physical offset 80. We have the signature, which is the PE signature. Machine ID and so on, all the physical offsets. We can then, since we invoke the edit functionality, now Hiew offers us one more dialog to see which field you want to edit. So we scroll and say you're redirecting the entry point. You want to change the entry point from one location to another. You edit the header, you locate the entry point somewhere here, and you can then select to edit it. So once you select the field you want, then again you press F3. So I press F3, and now here I can put the value I want. And like this, I'm changing the entry point RVA. You can change most of the fields in the PE header. Number of directories and other things you deem necessary. Then when you're done, you press F9 to update and commit the changes. So I'm gonna press escape to exit this dialog. So this is the header edit. So not only we invoke the show the header, we now show you how we can edit the header. We have F4 that takes us to the header. So it will take us to the PE header. F8 one more time. And another thing is entry point. So instead of like interpreting the fields by hand and going to the entry point, so here let's say close this dialog, escape, and we can always seek by pressing F5. So here instead of typing some value and seeking like this, we can simply press F8 and we have a built-in functionality F5, go to entry point. And here we go, we're at the entry point. Now, when I jump to the entry point, you notice suddenly I'm in the disassembly view. Of course, this did not happen by its own. I pressed enter to quickly as well see it in disassembly. Because what's the point to go to the entry point if I'm gonna look at it just as bytes? So when I pressed F8 and F5, I immediately pressed enter just to go to the disassembly view. And so That's not the topic for today in the disassembly view, but just for you to know that how powerful Hiew is, you have a built-in disassembler with nice virtual addressing that you can see, and so on. And that will be super powerful, especially those numbers, the way that they will let us navigate, and then other things we'll cover, such as assembling code on the fly, and so on and so on. Anyway, today we're covering the headers. So let's switch back to the hex view. So I'm going to press enter, enter, and go back to the header by pressing F8. So we saw the entry point. Now what is this object table? So what's object table? Now, object table is a generic term depending on the input file. Since we're dealing with a PE file, object table really means image section header. Now, Hiew supports different executable file formats. Now I'm working with PE files. So object table will show me the sections. So here already we know we have 7 sections. So if I press F6, within that dialog, I should see the 7 sections of the file. Here F6, and these are all the sections. And that's a nice view. We have comprehensive view about the most important stuff. What's the virtual size, RVA, which we add to the image base to get the full virtual address, physical size, physical offset, and the actual section flags. So this dictates the section, the SCN constant. So is it executable? Is it initialized? Is it read? Is it write? Read, write, etc. But we can still do more stuff. For example, we can, if we press enter, it will jump to the beginning of the section. So it will jump to the location. So if I press enter, it took me here to the beginning of the text section. As usual, since it's text section, I have no real value looking at hex, so I can press enter to see that section directly as a disassembly, and so I can look at things. Let's go back to the section view and show you other stuff applicable here. So we can add a new section. So that's really nice. You don't have to use a third-party tool. You can actually add the section. So if I press F4 here, it added a new section. Uninitialized, it just computed like where it should lie based on the previous information, the previous RVA, and the actual rounded virtual size rounded to the page. So it's the next page after this one, after TLS. I gave it a dummy name, and then we can press F3 to edit the section. So either I'm editing the new section or the existing section, doesn't matter. I press F3, and then now I have the individual fields. And then again, I can press F3 again, for example, to change the name here. Say, give it a different name and press enter, change the virtual address. So you can do basic PE fields manipulation. And that's very handy if you're patching binaries or neutering malware and so on. So that was F6. We could see the header, the sections, and that's going to be the same for ELF files and Mac O files. You would see their sections. Maybe ELF will have more sections than this. You can edit them, view them, jump to them, and change their characteristics as applicable. Even you can actually reorder. This is an interesting feature here where you can move things around. You can move a section definition up and down, so F11 and F12. So for example, it's not necessarily the right thing to do. If that's what you want, you can do it. So let's shift it down by pressing F12, and that's gonna move the text section into the actual PE header down one entry. Don't save the changes. Another important feature is the imports. So while still in the header field, you can press F7 to see the imports. So imports, we can see the imports as well. You can see the DLLs and so on. And we have as well additional functionality. So we can also sort by name, by DLL, and so on. And we can also filter by DLL and filter by API name. So if we say, for example, filter by DLL by pressing F10, and say kernel, and I just kept the kernel stuff. I get rid of the other APIs. If I select an API and press enter, this will basically take me to the first code cross-reference. So already that's something powerful. So here you saw quick dialogue. Hiew was searching for cross-references, and it took me to that cross-reference. That this address here, this code uses the getproc address, and nice we can see the hints that what is being resolved, and so on. And we don't have enough context like in IDA. While here, yeah, luckily we could see the get module handle for MSVCRT, and then so we could tell the logic here without even invoking IDA. We have quick answer, for example. So let's go back to the header. And now go to the another F8. Now, what is this another F8? So we're already in the F8 dialog, which is the header dialog, but then here Hiew as well offers us an old header. This might not be applicable for other input files. For like the MZ files, we have multiple headers. We can even have 3 headers. DOS header, new executable header, and a PE header. So, but in this case, right now, we have just the DOS header and the PE header. By default, Hiew prefers the modern header, so we saw the PE header when we pressed F8. And now if we really want to see the DOS header, inside the F8 dialog, we can press F8 one more time. So here F8, and now I'm actually looking at the DOS header. The DOS header is way simpler back in the day. Things that we can look at, let's say I want to really inspect that entry point that I retrieved the information from the header information. I want to see the code behind. So I know the physical offset 40, for example. So all I have to do really is seek, press F5, and go to the dialog. So here, type the number 40. So this is the actual entry point of the DOS header. And we can see some kind of small program actually in here. Like something says this program cannot run in DOS. This is just for compatibility reasons. If we have that binary in DOS and run it, there's no Windows, the exe will not crash. It will execute the 16-bit code here, and that's the entry point. This is the beginning. So we can also inspect that code, but we know this is 16-bit code. So since we're focused here, we use the F8 to get the old entry point. We can switch back to disassembly, but Hiew automatically knew that we are in that region where it should show in 16-bit mode, but otherwise we could have changed it. So here nicely Hiew disassembles as 16-bit. So here we can see proper instructions. If you've programmed for DOS, you can see this is exit, 4C function to exit, 01 exit code. Interrupt 21 for DOS interrupts. Function 9 and AH is to print a message, and the message is at E. And E basically is where that if we map this binary in the way the old header wants, address E at the data segment offset E, we should basically be pointing to this exact string. So this program cannot be run in DOS. So in reality, this is just the older header that if we run the program, it will display the message here to display that message and then terminates. So it doesn't crash. Now, one more thing here, we have exports. We don't have exports since this is an executable. So let's go and navigate to an executable. For that, I can use Hiew itself to navigate and open another file without closing Hiew. So Hiew can support multiple open files at the same time. So press escape back to Hiew. Now here in Hiew we have something called files. If we press F9, it will open a file manager. So I'm going to press F9 and navigate to Windows, syswow, for example. Let's just take a 64-bit program and select kernel32.dll. I'm picking another binary so we can see the exports in the header. Since today we're covering the header and some auxiliary functions along the way. So enter, and now we can have the F8 functionality. So let's press F8 as well to see kernel DLL header. So F8, I have the same story, same information, sections, etc., but this time we do have exports. And we might have imports as well. So kernel32 does import stuff. But now let's inspect the imports. So we're going to press F9. So here in the F9 window, we see all the exports. And the nice thing about Hiew is that it can also show us which one are forwarded exports. So here, for example, this functionality is exported. So the equal sign here is a good indicator. So here, I can see here that DLL is redirected to this and so on. But majority of the kernel32 DLLs are forwarded. And so we can browse in the export list. Same story, we can filter by pressing F9. And if we pick one and press enter, it will take us to the body of that function. So right now, like this, I can quickly jump to export. So if you're reversing a DLL, Open Hiew, switch hex view, F8, show the headers window, then F9, you see the exports list, you pick the export and you jump to the implementation real quick. So you don't have to open IDA just to see where the function, exported function is implemented to take a quick peek at its body or if you want to patch it or something. So press enter here and I'm at that function. And here we have nice names as well. Since those addresses map to the exports, you support names as we'll see in future episodes. And here we have nice names just because those names could have are computable. So Hiew gave the names because it knows how to give the names. But Hiew is programmable, and we'll see that we can actually interchange symbols between, like say from IDA to Hiew or something else and so on. Or you can build the names as you go from within Hiew. So this is basically the F9 dialog. Now let's see the directories. So this is also useful. The directories will show you the image data directories in the PE file. So if I press F10, there are 16 directories. That's it, we can't have more than that. So if I press F10, and these directories actually, like the index 0 of that directory is the image export, and the next one I forgot, but there are those indices. One is debug directory, one is import, one is export, and so on. So now if we press F10, we get to see those directories. So if I press F10, and here are the directories, and nicely Hiew also gives us the nice names. So here export is the first one, import, resources, and we get exactly what we know if we worked with the PE file format. This is the information we usually have for the directories. So here we can go to the actual export directory, but we'll see it in its raw form. So it's not useful for us. But what we can do from this dialog is actually patch it out. If you want to completely get rid of exports, all I have to do is say select the export directory and edit it, and then clear out everything, and that executable no more have exports. But otherwise, apart from editing them or clearing them, if you press enter, it will just take you to the raw data. So here it's not gonna be useful for us humans. So take a look, like it's not super useful for us yet, at least, unless maybe we can annotate this and color it and so on, then yeah, that's a different story. So let's go back to the final functionality here is the TLS, and that's also useful for malware reversers. As you know, TLS is the first thing that gets executed. So we as reversers, if we're tracing or running, we want to make sure we're tracing from the beginning. So TLS is the beginning before the entry point. So here, when we inspect the header, just to get a quick overview of the binary we're dealing with, we can tell quickly if there's TLS, if the TLS functionality is enabled. So if I press F11, Hiew nicely parses the TLS callbacks for me. So this is the nice functionality about Hiew, that it has so many specialized subviews to visualize certain fields for us. If I jump to them, I will see the code. So here, this is the first TLS callback. Going back to the header, as well, there is one more functionality for resources and so on. So I hope you found this useful. This is just the introduction, and the future episodes we're gonna talk about more and more advanced features. For now, if you found this interesting, please leave some comments. Let me know if you're interested in more continuation or specific topics or questions. Otherwise, thank you, and see you next time.